This chapter is begin with the school student. His name is John. He brought a new computer at his home. He was very excited with the new computer and he asked the computer to perform the calculation 250 plus 150. But the computer replied that he doesn't understand what does it mean. What happened here? This is because John is using decimal numbering system for the calculation. He see the number in decimal form, but the computer, they see the number in binary form because they are using the binary number system. So in this situation, normally whatever John instruct to the computer in decimal, the computer cannot understand that. In the same way, whatever the computer give the output in binary, John cannot understand that easily. So in this situation, a decimal to binary conversion as well as binary to decimal conversion is required between the communication between John and his computer. In this chapter, we are going to talk about the decimal to binary conversion and binary to decimal conversion. Welcome to the video. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 53, Decimal to Binary and Binary to Decimal Conversion.
Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar.
In this chapter, we will talk about how to convert a decimal number to binary, and we will talk about how to convert a binary number to decimal. Humans are very smart because they invented the computer. At the same time, computers are very smart because they help humans in each and every task. But in normal cases, the communication between them are not compatible because the computers are using binary numbers to process a task because they use the chipset based on the digital electronics. But on the other hand, humans are using decimal number system to indicate a number. So when the computers and humans work together, they need to do a conversion of decimal to binary and binary to decimal. So the second party can understand what the first party instructed. If we say it in simple way, the decimal number system from the human must convert into binary number system so that the computer can understand the instruction. In the same way, the binary number system from the computer output, it must convert it into decimal number system so that the human can easily understand the result. So who is performing here this conversion? Is that mean like when human give some task to the computer, he need to use a calculator or any paper and convert this decimal number to binary number system? No, it doesn't require because the computer operating system, the computer's chipsets are designed to perform this conversion automatically. That means humans can give the instruction in decimal number. The computer operating system and the chipset work together and convert that decimal number system into the equivalent binary number so that computer can process that task easily. So in this chapter, I will show you how to convert a decimal number into a binary and how to convert a binary number into decimal. Let's see how it is happening. Decimal to binary conversion. If you want to learn the decimal to binary conversion method, then first you need to visit Martin Brick Shop. Who is this Martin? Martin is my friend. He is an entrepreneur. He started his own brick shop. He make quality bricks for the construction purpose. And this is the most demanded bricks in his neighborhood. So he get too much business from the people around him. So many people coming to his brick shop and buy the bricks for their construction jobs. So in the Martin Brick Shop, there is a counter table. We can call it reception. And Martin is the one who manage this reception. So when the customer reach to Martin to buy the bricks, they give the order at the reception. Once Martin received the order from the customer, then he create an order list, then transfer that to his assistant. And his name is Bob. Bob is working at Brickyard. So whenever Martin processes an order, he transfers that order to Bob. Then Bob go to the Brickyard and collect the number of bricks as per the order, then use his trolley and then deliver to the truck. Once it is loaded into the truck, then truck will go to the customer premise. So this is the process happening in the Martin Brick Shop. There is only two employees. One is the owner, cum receptionist, Martin itself, and his assistant Bob. Now let's see what is the operating process in the Martin Brick House. As I said, Martin is the owner cum receptionist. He's always sit at the reception to receive the order. So the customers can directly approach the reception and they can give their order. So let's imagine one customer came to Martin reception and he ordered 230 bricks. He need 230 bricks. So as soon as Martin received this order, he instruct Bob, hey Bob, I need 230 bricks from our yards and load into the truck so the customer can take that to his premise. So Bob collect that 230 bricks from the brickyard, then use his trolley, then load into the truck of the customer. Now let's imagine a second customer came and he need 150 bricks. Then Martin received that order and he instructed the Bob, hey Bob, I need 150 bricks from the brickyard. So again, Bob need to go to brickyard and collect that 150 bricks and use his trolley and then load into the second truck of the second customer. Now imagine a third customer came and he need 88 bricks only. So Martin collect that order and instruct the Bob, hey Bob, I need another 88 bricks for the third customer. So the Bob go to the yards and collect that 88 bricks. Then he load that into the third truck that belongs to the third customer. Now you can see here, Martin is always sitting at the reception and he take the order from the customer. But in background, there is only one person to do the job of collecting bricks and loading into the truck, and that is our poor Bob. So whenever Martin give a number to Bob, Bob need to go to bricks yard and then collect the number of bricks as per the requirement and load into the truck. That means he need to always run between the brickyard and the trucks. So let's imagine here the first customer came and he need 230 bricks. Martin already instructed Bob to collect 230 bricks and to deliver. So the Bob started the job. He was collecting the bricks one by one, filling in the trolley and loading into the truck. And meanwhile, our second customer came who needed 150 bricks. He also gave the order. So Martin give another instruction to Bob. Hey Bob, we need to give another 150 bricks to the second customer. But in this time, Bob is working on the first customer order. He cannot go to the second customer order without completing the first customer order. That means without completing the delivery of that 230 bricks ordered by the customer 1, Bob cannot process the 150 bricks order from the second customer. Then again the third customer came and he need 88 bricks. Again Martin gave the instruction to Bob, Bob, another 88 bricks we need. But Bob cannot perform this third customer order without completing the first and second customer order, because they came first and they ordered first. So on the priority base, Bob need to fulfill the requirement of customer 1, customer 2, customer 3. In this situation, the customer 3 need only 88 bricks, but he need to wait there till Bob complete the customer 1 and customer 2 order. So we can see here in this process it is taking too much time. And who is the most dangerous situation here? It is Bob, because he is the one running between the bricks yard and the trucks to fulfill the customer order. So this is very difficult for him to manage. So when the number of customer increased, there was a delay in delivery of the bricks because it is taking too much time to fulfill their order. So Martin tried to find a solution to make this process easy. So let's see what is the new process. So according to our new process, Martin find a way to make the process easy. The first step is divide the bricks into multiple groups. And in this group, the number of bricks are not the same. Martin created 8 groups of bricks with the number of bricks are equal to 2 power of the 0 to 2 power of the 7. That means the number of bricks at each group has a value from 1, 2, 4, 8, 16, 32, 64 and 128. So here if you look at here, you can see these 8 groups has different value because here Martin use a binary number system. It's also called base 2 number system. So here to the first pellet group, Martin give the value 2 power of the 0. That means 1. Any number with the power of 0, it is calculated as 1. And the second pellet group, its value Martin give as 2 the power of 1. So its result is 2. Any number with the power of 1 is called the number itself. For example, 2 to the power of 1 is equal to 2. What if 3 to the power of 1? It is equal to 3. What is 4 to the power of 1? It is equal to 4. Because any number with the power of 1, it is equal to the number itself. Now the third one, Martin give the value 2 to the power of 2. That means 2 into 2 is equal to 4. This one. Then the fourth one, 2 to the power of 3. That means multiple 2 3 times. And what we get? We get 8. This one. Then the fifth one, 2 to the power of 4. That means multiply the number 2 4 times. That is here. And that is equal to 16. Then 2 to the power of 5 here. That means multiply the number 2 5 times. So 2 into 2 into 2 into 2 into 2. That is equal to 32. Now if we go to the next one, 2 to the power of 6. Multiply the number 2 6 times, then we get the 64. Then 2 to the power of 7, multiply the number 2 7 times, then we get the 128. So as shown in the image, Martin divided the bricks into different pellet with a different number of bricks. And by using this 8 combination of the bricks group, he can make the orders up to 255 bricks. For example, if any customer came here to buy the bricks, if their value is 255 or less than 255, then by using this 8 group, Martin can deliver the bricks to the customer. Let's see how it is doing. In addition to this classification of bricks, Martin brought a bunch of green flags into his office. So whenever he receives an order from the customer, he will take the flag and mark the group of the bricks accordingly. So the Bob can easily take that selected bricks, then load into the truck. He doesn't want to count himself. Instead, Martin already calculated the number of groups to fulfill that customer need, and he mark it with green flag. So Bob just need to see where is the green flag it is, which group has green flag. He can immediately take that pellet and deliver to the customer. So this make their process very easy. And how it's make easy? Because Bob doesn't want to count each and every brick from the brickyard and load into the truck. Instead, Martin already made the calculation according to the customer order. Then he selected the pellet using his green flag, and Bob just need to collect that pellet and deliver to the customer truck. That's it. So let's see how Martin is making that calculation. Just imagine our first customer. He need 230 bricks. And as soon as he give the order, Martin go to his brick templates where he classified the bricks into different groups. Then he will start marking the bricks as per the customer order. So how Martin is going to mark the bricks? Let's see. Here the customer need 230 bricks. So Martin see which one is here with the large number of bricks group. It is the left side one, 128. So Martin mark that group with the green flag. So here the customer was needed 230 bricks, and Martin already selected 128, that single group. Now what is remaining? It is 102. Martin still need to choose 102 bricks. Then Martin went to the second group of bricks from the left side, and it has 64 number of bricks. Martin need here 102, and this group has only 64. So anyhow, Martin selected that second group as well. He marked the 64 bricks from that group. So the previous 102 requirement minus 64 is equal to 38 bricks. That means Martin still need 38 bricks to make the count 230. So Martin went to the third group, and there 32 bricks are available. Martin need 38 bricks, but this group has only 32. Anyhow, Martin selected that third group, and then the required number of bricks was reduced to 6 because 38 minus 32. Martin still need 6 bricks to complete the order. So he went to the fourth group, and when he checked the number of the bricks, it is 16. Here Martin need only 6 brick, but the fourth group has 16 bricks. So can Martin take that group? No, because it is more than the number of requirement. So Martin didn't select the fourth group, the 16th brick group. He went to the 5th brick groups. That is also contain 8, but Martin need only 6. So he didn't select the 5th group as well. He went to the 6th group. That contained 4 bricks. So he selected that group. So his requirement was reduced to 2 because previously he was needed 6 and 4 selected, then remaining is 2. Then Martin went to the 7th group and selected that because it has 2 bricks, and the final number that Martin needed to fulfill the first customer order, 230 bricks, it was remaining 2. So he selected that. So 2 minus 2, it's become 0. That means Martin completely fulfilled the requirement. So here you can see Martin selected 5 groups of bricks. So by selecting the 5 group of bricks, Martin can deliver the customer requirement 230 bricks. How easy it is. So after Martin selected all these groups, Bob can easily identify that group with the help of a green flag. He can easily take that pellet and deliver to the customer truck. It is so easy. Here Bob doesn't want to run behind the brickyard and customer truck by counting the bricks. Nothing. Martin already selected the brick. Bob just need to take the bricks and deliver to the truck. That's it. Now let's see here. The customer wanted 230 bricks, which is a decimal number. And here, according to the customer need, Martin selected some of the groups from the brick templates. So wherever Martin marked the group, that is only considered by the Bob. So Bob consider wherever the flag is available with a value of 1 and wherever there is no flag with a value of 0. So when we consider like that, we get a value 111001110. And my friends, this is the binary equivalent of the decimal number 230. This is how a decimal to binary conversion is happening in a computer. So any decimal number can be converted into a binary number with the help of these templates. By using this template, the maximum value of decimal number can be converted is 255. If the value is more than 255, then the number of bits need to increase. Here you can see there are 8 bits, 8 group of bricks. By using this 8 group of bricks, we can get maximum value of 255. So if there is a value more than 255, then the 9th bit need to add to our templates with the value of 256. Now let's see how Martin is going to process the order from the second customer, that is 150 bricks. So Martin, after he received the order, he went to the brick templates and he need to select 150 bricks from this group. So he went to the first group from the left, which contained 128 bricks. So he selected that group and he marked with his green flag. So 150 minus 128 is equal to 22. Still 22 bricks are required to fulfill the customer order. Then Martin went to the second group, which has a 64 bricks. So Martin didn't select that group because it contained more bricks than the required one. Then he went to the third group, it has 32 bricks. He didn't choose that even because the numbers are high. Then he went to the fourth one, it has 16 bricks. What Martin required is 22 bricks. So he selected the fourth one and marked with his green flag. Now the number of required bricks are 22 minus 16 is equal to 6. Then Martin went to the next group and it has 8 bricks. So he didn't select that. He went to the next one, it has 4 bricks and he needed 6 one. So he selected that group and mark it with the green flag. And again, still required numbers of bricks are 2 because it is 6 minus 4. And again, Martin needed 6 but he got 4. That means still 2 more bricks is required. Then Martin went to the 7th group, which contained 2 bricks only. So he marked it with his green flag. So 2 minus 2 becomes 0. Martin fulfilled the requirement of 150 bricks. Then he instructed Bob to collect the highlighted groups and load into the customer truck. So Bob came here and wherever the green flag is available, Bob mark it to 1, and wherever there is no green flag, Bob mark it 0, and he collected only the group which has a value 1 and load into the truck. So here we get a value 100101110, and that is the binary conversion of the decimal value 150. Now let's go to our third customer who need 88 bricks only. So Martin went to the bricks template and he went to the first group which contained 128 bricks. So he cannot select that one, the numbers are higher. Then he went to the second group which has 64 bricks. So he selected that one and marked it with the green flag. Then the number of requirement was reduced from 88 minus 64 is equal to 24. Martin still need 24 bricks to complete the order. He went to the third group which contained 32 bricks. He didn't select that. He went to the next group which has 16 bricks. So he selected that one and marked it with green flag. Then still he need 24 minus 16 which is equal to 8 more bricks. Then he went to the next group which contained exactly 8 bricks. So he selected that and marked it with the green flag. Now the number of bricks needed is 0 because 8 minus 8 is equal to 0. Martin fulfilled the requirement. Then Martin asked Bob to collect the pellet groups of bricks and deliver to the customer truck. So Bob came and he chose wherever the flag was implemented and he put the value 1 for that thing, and he put the value 0 for the group which is not selected by Martin. So we get a value 0 1 0 1 1 0 0 0, and this is the binary equivalent of decimal value 88. So this is how we convert a decimal value into binary. Just remember what method Martin was using in his brick shop. He was categorized the bricks into 8 groups, and we can call this group as a bit. We can call it 8 bits. So by using 8-bit, the maximum number of decimal number we can mention is 255. If the decimal value is higher than 255, then we need to add additional bits at the left side in order to complete that conversion. Now let me give you some homework to do the decimal to binary conversion. So I give 3 number here, 3 decimal number, and you need to convert this decimal number into the binary yourself, because you already learned how to convert a decimal number to binary. So if you already did this conversion yourself, then it is very good. You have learned the concept. But if you cannot do, I will show you how to do this conversion yourself. For that, same like Martin, consider the bricks templates. We need to consider our templates here, which has a value 1, 2, 4, 8, 16, 32, 64 and 128, and each value consider as a bit. By using this 8-bit, we can consider the decimal value up to 255. So let's see how to convert these numbers. Our first number is 173. Okay, so I am going to the left side. The first bit, its value is 128. So this 128 is it coming under the 173? Yes, because 173 is higher. So I select the 128. I give a value of 1. Then I went to 64. Then what is the value remaining? What I need to convert is 173, and what I got it here 128. So 173 minus 128 is equal to, still I need 45. Okay, then I went to the second bit, which has a 64, but I cannot choose that thing because I have only 45 to complete. So I will mark this bit as 0. Then I will move to the next one. It has a value of 32. It is coming under 45. So I will select that and I will give a value of 1. So what is remaining here? 45 minus 32 is equal to 13. Now I go to the next one. Its value 16. I cannot choose that thing because I need only 13. So I give the value 0 here. Then I go next. It is 8. I will select that thing because I need 13 and 8 is coming under 13. Now the number of requirement is 13 minus 8 is equal to 5. Then I go to next, which has a value of 4. I will take it and mark it as a 1 because I need that. And the number of requirement become now 5 minus 4 is equal to 1. Then I will go to the next one. It has a value of 2. So I cannot select that thing. I will make it 0. Then next one is 1. What I need exactly is the 1 and what I have is 1. So I will select that thing. So number of requirement minus number of selected is equal to 0. So here I get the binary equivalent for 173 decimal. 173 is equal to 10101101. So this is the binary conversion of the decimal value 173. Now go to the next value which I need to convert is 255. So I will go through the binary templates, and first one is 128. I will select that thing. So what is remaining is 255 minus 128 is equal to 127. Then I go to the next group and it has a value of 64. I will select that. Then what is remaining? 127 minus 64 is equal to 63. Then I go to the next one and it has a value of 32. I will select that. Then what is remaining is 63 minus 32 is equal to 31. Then I will go to the next group. I will select that. It has 16 value. So 31 minus 16 is equal to 15. Then I will go to the next one. It has a value of 8. I will choose that. Then 15 minus 8 is equal to 7. Then I will go to the next one. It has a value of 4. 7 minus 4 is equal to 3. Then I will go to the next one. It has a value of 2. I will select that. 3 minus 2 is equal to 1. I will go to the next one and it has a value of 1. I will choose that because I need exactly the 1 is here. So the decimal value of 255 is equal to 11111111. So this is the binary. So the binary value of the decimal 255 is equal to 11111111. So this is how we convert the value of 255 into the decimal. And here you can see in this 8-bit we have selected all the bits from here. That's why I said earlier, by using this 8-bit, the maximum number we can make is 255. If the decimal value is 255, we need to select all the bits from here, and the 255 value is the addition of all this bit together. Now let's go to the third exercise, which is the conversion of a decimal value 500. So as I said earlier, by using the 8-bit number, we can convert maximum value 255. If the decimal value is higher than 255, then we need to add additional bits to our templates. So here I am going to add additional bit, that is 256 here. So when you calculate the number of bits, 1 2 3 4 5 6 7 8 and addition 9th bit I have added here. Now let's do our calculation for 500. For 500 we have here 256. I selected that thing. So 500 minus 256 is equal to 244. Then I went to the next group. I selected 128. So 244 minus 128 is equal to 116. Then I went to the next one. I selected that. 116 minus 64 is equal to 52. Then I went to the next one and I selected that. 52 minus 32 is equal to 20. Then I went to the next one. I selected that. 20 minus 16 is equal to 4. Then I went to the next one, but I didn't select that because its value is higher than what we needed. So I made it 0. Then I went to the next one, and here I have 4 and what I need is 4. So I selected that thing. So it will match with my final requirement. Then next 2 is considered as 0. So here the decimal value conversion of number 500 is equal to 111111010. So this is the value we get. And normally when we write the binary, we make 4 bits as together. So this as together, and when we do that thing, this one is alone here. So this 500 we can write as, this one we can write as 0001 because it has the value of 1 only. Then next one 1111, the next group 0100, and this is the binary conversion of decimal value 500. Now I will give you one additional homework, that is convert the decimal number 1010 into the binary. So as you know, by using 8-bit we can only convert maximum 255. So if we want to use 1010, then we need to use additional 2 more bits. That makes our total number of bits templates into 10 instead of 8. Now let's see how we can convert the decimal value 1010 into binary. So what is our value is 1010. So when I go to the first one, it has a value of 512. So I select that thing. So 1010 minus 512 is equal to 498. We still need 498 to make the conversion. So I will go to the next one, which has a value of 256. So I will select that thing. Then 498 minus 256 is equal to 242. Then I will go to the next one. I will select that. So here our value 242 minus 128 is equal to 114. Then I will go to the next one and I will select that. So 114 minus 64 is equal to 50. I will go to the next one, which has a value of 32. I will select that. 50 minus 32 is equal to 18. Then I will go to the next one, which has a value of 16. So 18 minus 16 is equal to 2. I will go to the next one, but I will not select that one because it has a value of 8 and what I need is only 2. So this is 0. Next one is 4. That is also 0. Next one is 2 and it is exactly matching with my requirement here. So I will select that one, and next one is 0 anyhow. So here 2 minus 2, which I selected, it's coming as 0. So the decimal value of 1010 we can write as 1111110010. And when we group the binary into 4 bits, we can write decimal value of 1010 into 00111111 0010, and this is the result of the conversion. So we have learned how to convert a decimal to binary. Now it is time to do the binary to decimal conversion. And this is our binary reference number, and we are going to convert into the decimal. To convert the binary to decimal, we need to consider the same bricks templates that Martin was invented. And so I brought the templates here, which has 8 groups of bricks and which has a value of 2 power of 0 to 2 power of 7. So here just consider our binary number which has 8 bits, and our templates also have 8 groups. So here we need to match each bit of the binary number into the each bricks group. So the first one, it will indicate here the 0, second one indicate here, third one indicate here, fourth one indicate here, fifth one indicate here, sixth one indicate here, seventh one indicate here, and the eighth one indicate here. So here wherever the value of 1, we will consider that value of bricks. And wherever the number of 0, we will not consider that one. We will make it 0 instead. So here the first one we have 1. What is the value of that number of bricks? It is 128. So I will mark that group with green flag. Then the second one is 0. So I am not marking it. Then the third one is 1. So I am marking that group. Fourth one is 1. I am marking that group as well. Fifth one 0. So I am not marking. Sixth one is 1. So I am marking that with the green flag. Seventh one is 0. So I am not marking. 8th one is 1, so again I am marking with the green flag. Now, so here wherever we mark with the green flag, which is indicating the number 1 in the binary, just consider that value and add together, then we get the equivalent decimal value of the binary. So here I am taking all the value that I have marked here. Wherever the 0, it consider as 0. Wherever the 1, it consider its value. So when we do addition, all this together, we get the value of 181, and that is the decimal equivalent of binary 10110101. So this is how we convert a binary number to decimal. Now let's go to the another example. The binary number is 11000110. Go to our templates, mark the value of 1. That means the first one, second one, then sixth one and seventh one, and take the value of all the marked group and add together, then we get our decimal equivalent of this binary. So let me do the addition here, and we get the value of 198. So the decimal equivalent of the binary 11000110 is equal to 198. Now let's do some homework. I am giving you few binary number and you need to convert that into decimal, and this is our templates. So we'll go with the first example here. So there are 8 bits, so I'm considering the 8 bit from the right side. The first one is 1, so I will make it here 1. Second one is 0, so this should be 0. Third one is 1, so making here this value here 4. Fourth one is 0, so it should be 0. Then the remaining 4 1, so that means this should be taken, this should be taken, and this should be taken. So when we do a calculation of all this value together, we get the decimal equivalent. So we get our final value is 245. So this is the decimal equivalent of our first question. Now let's go to our second example, this one, that is 10110001. So let's match it with our value. The first one is 1, so I will consider its value as 1. Then there are 3 zeros, so I will not consider this. I will make it 0 for the next 3 bit. Then we have 2 1 bit, so I will consider this as 1. I will take its value 16. The next one is also 1, so I will take it 32. Then 0, so that means the 64 I will not consider. Then 1, I will consider this 128. And when we do addition of all this value together, we get 177, and that is the decimal equivalent of our second question. Now the example third and fourth one, you need to do it yourself, because now you have learned how to convert a binary number into decimal. So do it yourself, and if you have any doubt, just comment me in this video so I can clear your doubt. Just find some example from the Google and do the conversion yourself and be master in this conversion. This is one of the basic mathematics rules that we are using in the CCNA, in computer networking, anywhere. So you just practice this thing, and especially the fourth example, you need to do it yourself. So in this chapter, We have learned how to convert a decimal number to binary, and also we learned how to convert a binary number to decimal. Thank you very much for watching, and subscribe to the channel for more videos. Enhance your skills using iRush Academy.